and then the threading cycles and boring cycles. Okay. In the previous programming we have done, in this you can observe that for this central drill and drilling, uh, after drill we again use the tool to move in the upward direction, and again we give that command of movement from one x and y direction again for the tool. So you can see over here, here the G01 Z minus 5 central drill is done this line G00 Z, that is the retracting of tool. So these cycles, CAN cycles are used. Suppose number of holes are there, or number of boring you have to do with some coordinates x and y coordinates. Then you have to use these lines again and again to retract the tool. To avoid this retracting line, you can use this drilling cycles, or so CAN cycles are for drilling, for milling also. Okay, and turning cycles are also there. Then do loop cycles are there. So we'll see today the drilling cycle first. So in the figure you can see that a reference plane is given. Okay, and it is at a reference plane is 30. So it is 20 mm above. Okay, 20. So 30, 30. Okay, so 10 mm above this reference plane is 10 mm above the surface of the component or the blank, and the tool is again 10 mm above the reference plane. Okay, so in this for the drilling cycle, the code used is for the drilling cycle, the code used is G81. As discussed in the starting sessions of G codes and M codes, the G81 is used for a drilling cycle. So how it works and how to write these codes in the block, we will see today. Drilling cycle. Okay, so in the drilling cycle, G81 code is used, and to cancel that cycle, G80 code is used. I am not giving the starting lines for showing this. I'm directly specifying the codes. Directly, I will use N05, G71, that is for metric unit, and G94, that is feed in G90, feed in mm per minute, and end of block. End of block. You can write EOB also, or you can write in this semicolon. Okay, so here specify that for the first block, the 71 is a metric unit. Then you have, again, if you want to give the please suppose, then you will give G17. We are considering this reference plane as an XY plane, and the G54. Okay, G54 is to save this work with 0 coordinate. Okay, then after this N10, then you can give the tool number M06, then T01. Suppose this is our tool number 1, T01. Okay, and the cylinder speed given is 500 RPM is there. Okay, and the feed given is 100 is the feed. Okay, 100 is the feed. So mm per minute. Then the depth it's going to travel is given up to this 50. You can see over here. So your depth will be 30, 30 plus this means reference plane. From this point, it is taken as the origin point. This is taken as a 0, 0 over here. You have to make this tool to insert this blank up to depth of 50 mm in y direction, in in z direction. Okay, in z direction. Okay, so you understood this. Okay, so this reference plane at this point z is 0. At this point z is 0. Okay, so only drilling one single operation I will use. Suppose for this cycle, number of holes are there. Number of holes are there means uh, I will take you over here. Suppose here is a hole. Okay, at a distance apart from this, I will take x. It is in x direction. It is 20 mm. 20 mm. Then how this retracting line can be edited, you can see this. Suppose you have given this, then N15 M03 has set the spindle and started the coolant. So started the coolant with the speed of this 500 RPM and speed is 100 mm. Okay, now I will give uh, the workpiece, the call that is G00. I will use, and I will use that G00 X0 and Y0. Suppose at this point of the origin, the X is also 0 and Y is 0 and Z is also 0. So I will use this X, Y and Z 0. Okay. And you have to drill two holes. You have to drill two holes. Okay. So for that N25. Okay. Now the tool is at this position X0 Y0. I have taken the center of the block as a reference point. As a reference point. So for drilling, I will use G81. G81. This is the CAD cycle for drilling, and I will use Z minus 50. I will use Z minus 50. How it will drill this hole up to depth, and you have to take the R equal to the extra of this is 10 R10. This is not related to radius, it is related to the breakthrough distance of the tool. Breakthrough distance of the tool R10. Okay. Then after this, again in the this previous problem we will use in this we'll use G00. Again we use G00 M30, and again we lift this to Z0. Okay, so to avoid this line, you are using this G81. So now instead of writing this G00, you can understand why it is used. Okay, instead of writing this G00, okay, instead of writing this G00, you can write in the next block as this coordinate. Suppose this is negative x direction, minus x. This is positive x. Okay, so positive x. So it is more towards again you have to write only minus x20. X20. You have to write minus x20. So it automatically retract this point. Again, the tool will move to its 0. Again, it goes over here, and again it will drill this up to z minus 50. Okay. Again, required to write this z minus 50 again. So this cycle of two holes are completed over here. Then you have to call the cancellation of the cycle in 35 G80. G80 is to cancel the cycle and end of the program. Okay, I will directly use end program N40 M02 for ending the program, not for resetting it. So in this way you can use this code. Then next for you will see for the peg drilling cycle or deep hole or peg drilling cycle. So in this peg drilling cycle, only one hole is there. Only one hole is there. First, it will drill up to this. You can see in this figure. First, it drill up to the depth of 15. Then it drill up to the depth of 25. Then it is drill up to this. Then last, it will drill up to this 10. So for this, we will the codes again. I will not use that G71 and the starting line. I will directly use the codes N07 G00 G00 X10. Suppose it is suppose this is my origin X10 and Y10. X10 and Y10 is there. Okay, Y10 is there, and the depth first depth should be of first depth. It will take -10. Then you can see over here Y10 end of block. So first depth you have to give this cycle, this peg drilling cycle for this N09. I will take N09 and Z00 G00 Z -10. Okay, Z -10. Z -10. So now my tool will move up to this point, that starting point. Okay, then after this I will use G82. G82 code. G82 is for peg drilling cycle. Code for peg drilling cycle code. Okay. So in this line, I will use suppose N11, N11, G82. Okay, now my tool is at this point, just touching the surface, Now G82 is -90, Z -90. So this 15 plus 25 plus 25, 50, 50, this 70, 70 plus this 10 plus this reference 10. So total it is 90. Total it is 90. We have considered this point as a 0, 0. So you have to take -90. Okay, -90, and you have to write the K value. Now what is this K value? Is that it is an incremental depth after which the tool has to be withdrawn. So first it will take 25 mm, then again 25 mm, again 25 mm, and last it will complete the 15. Okay, so in this way, K value is the as we use R value for the for this in this drilling, we use the R, that is breakthrough distance. In this, K value is used. So this distance is 25, 15 plus 10. Again the next is 15. Again the next is 15. Sorry, 25. This is 25. This is 25, and this is 15. Okay. So you have to take this K value as 25, and you have to give the feed rate of 100 or whichever is in the problem. Okay, whichever is given in the problem. So after this line, you can cancel the cycle. So it will first, if you use this block, it will first depth this. Again, it will depth this. Okay. Again, next, again it will depth this. Again, it lifted upward. Again, it will depth this. Okay. So in this way, this cycle works. Okay, and again you have to use G80 to cancel the peg drilling cycle. So G82 in this way you can use this. This K you have to remember it, and you have to give the entire depth of the drilling, Okay, and you have to use the main sequence of the first is 25. So depth of cut you have to give in this. So K is nothing but incremental depth. So it will not take the origin. From this it will take 25. From this it will take as 0 again. It will take 25 and 20. Okay. Next, uh, this at this point, if it is 25, okay, this is 25, this is 25, this is 25, but this is 15. So at this point, it will give reference that you have to go up to only 90. So at this time only it will go 15. Okay. So make sure it not go beyond this point, because you have restricted or constrained that depth as a z minus 90. Okay. So K is nothing but incremental depth after which tool has to be has to be has to be withdrawn. Has to be withdrawn. Okay. So in this way the peg drilling cycle works. Okay. The next one, if there is a threading is there, if threading is there, threading of the same hole is there, threading cycle is used. So how it works, we will see. So in this threading cycle, as we use the G81 and 82, so in this case, G84 is used. G84, and it is used for boring cycle. So if a boring is there, only G83 you have to give, and the depth. Okay, and the depth you have to do nothing. Kn values are there in this in the case of boring. G83 is for boring cycle. Boring cycle. So and for threading cycle, G84 code is used. Okay, cycle G84 code is used. So suppose this is also at the distance of x and y distance is 10 10, and we are considering this as origin of that workpiece. Then how to write this? Then 05 G00 G00 x10 and y10. We move that tool. Then we have to move that tool to the depth that is minus 10. So we have to move this from this origin point, reference plane point. So the origin should be over here. The origin should be over here instead of this, because it is taking this reference plane. Okay. So this, from this origin, it is x is 10 and y is 10, and it is working downwards. Okay. So n 10. Now G00 Z minus 10. So now this tool will be at this position. Just touching the surface when we do Z minus 10. Okay. Now we have to use that threading cycle N15 G84. That is a threading cycle G84, and the depth is 25. You have to give the depth Z minus 25, and you have to give the feed given as per the problem, or not given, you have to just consider it 100. End of block. And again the next line, again you have to use G20 G80. Okay. So number of holes are there, number of peg drillings are there. So in this peg drilling, this cycle will continue with the depth of 25. But in this case, the tapping cycle, if tapping cycles are more, suppose number of holes are more, then only you have to give the coordinates over here, x coordinate and y coordinate, and it will work similarly up to you have used the G80 code. When you have cancelled the G80 this threading cycle, then only it will stop. So in this case, the cycle is used to save the retracting of the tool. Okay. So we will see one example of this. All this will be there. Only center drilling is there in this problem. Then drilling of 6 diameter is there. Then again 8.5 diameter is there, and there is a tap. So threading cycle and drilling cycle will be there in this problem. We'll use how to use the problems if number of holes are there. Number of holes are there. So this problem is related to CAD X cycle example. So in examination, this kind of problems are asked for drilling and tapping or threading. I will say threading. Okay. So we are considering this as a Siemens control. So use, we'll start this. Use percentage sign, then use M, suppose 1, 1 to 5. Okay. Then don't use 1 to 5. Okay. Then N10, N10, we will give first G17. That will be the working plane of this. Okay, working plane of this. Then G90, that is we are using absolute coordinate system. Then next one G94, G94 we are using the feed rate in mm per minute. So the given feed rate is 125. 125 is given for drilling. For uh, drilling and central drilling, they have given you 125 feet rate, and for tapping or threading operation they have given you a feet rate of f equal to 300, and the speed is given for this is for this is threading. Speed given is 300 rpm, and sorry 300 200 rpm, 200, and for this they have given you 800 speed. Cutting speed is 800 rpm for drilling and center drilling and all. Okay, so G17 we are considering this is as a XY plane. G90 as your absolute coordinate system. You are considering G94, that is we are considering that this is in mm per minute, and then G71, G71, and that is for metric unit. We are considering this all these dimensions are in mm. Then after this is we will use G17, G55 to save this work with 0. Okay. Then after this we will give the uh, tool number. Suppose this is the tool number 1. So we have to, in examination you have to specify if they have not given you the tool number and all, you have to specify over here. So T01 is the center drill, center drill. Then T02 is your finish drill. T02 is finish drill. What is the diameter for that is, you have to see this 6 diameter. Okay, and then again next tool T03, we have to specify that T03 is a pre-drill tap hole. So this is of diameter. So it is previously they have given in the problem is that it is a previously drilled holes are there, and you have to just a minute. I will check that. No, it is 8.5 diameter. So pre-drill tap hole. It is of 8.5 diameter. Okay, so these are the holes. 1, 2, 3, 4, 5, 6. Okay, so previously it is in this problem they have given you that holes are drilled, and then you have to use this 8.5 and diameter pre-drill the tap, and then you have to use the tap of sorry twist drill, and then you have to use the tap of M10 given in this problem. M10 T04, the tool number 4 is a tap of M10. Okay, M10. So starting with first tool P06 by the first tool. So M06 M M06 T01, that is your center drill, and specify the speed for that S800 S800 and feed rate 125 given 125 given, and you have to start the spindle M03 and M05. You can use this over in this N15 also, M03 then M06 then in this way, sorry M08 M08. Okay, so to start in the coolant. Okay, so after this lines will be the similar one. Now we have to give the coordinates line blocks for part programming. So for that N25, okay, and we have to give the cycle. The cycle is for center drilling cycle. What are the code for this? Okay, so drilling cycle G81 is used. So I will use G82 instead of that. G82 instead of G81 in this, and I will use the peg drilling cycle to drill the center drill of all holes. Of the all holes are there, for all holes I will use. So G82 peg drilling cycle X20 Y34 Z minus 5 and R2 is the breakthrough distance. Okay, so this is for you can see over here, it is for X20 and Y34. So it this is the origin of your workpiece. This is the workpiece 0. So from this hole will be drilled first. When you call this cycle, this will be your 1 number, then this will be your 2 number. Give that coordinates. Only in the next line you have to give the coordinates. That is 84. You have to give only 84. Okay. So X has been given, so no need to write again 84. Why 84? So it will drill this central drill this. Okay. So retracting line is not required when you use the cycle. Okay. So that is the case. 35. Then next hole central drill for this 2 holes. After this G80 I will use, or you can drill holes for all this. Okay, so for that you have to use, I will use, suppose this is my 1 number, this is my 2 number, this is 4, 5, 6, 7, 8, 9, 10. Okay, you can take as per your choice. 1, 2. Just here to in diagram, you can show this numbering 1, 2, 3, 4, 5, 6 in this way, so that the examiner can easily identify that. Okay, so next one is you can see X is changing. X is changing to 20. X is changing to 20. Then Y X is changing to 20. and y is 84. Y is remain same. Y will remain same. So x you have to give only x 60. Okay, x 60. N 40. So fourth number, there is y will change. Now x will remain same. X will remain same for this entire holds 3, 4, 5, and 6. X will remain same. Okay, because it is in the same line. Okay, so only you have to give the y distance. So y 60, y 60. Then next n 45, y 40. Okay, n 50. That's right, 60, y 60. Okay, then next for the whole number 1, whole number 7, I will use again the x changes. So you have to write x x x is 95, 95, and y will remain same. So no need to write y. N 60. Again x will change. It is 115. Okay. Then again for I will use as a ninth number this one, this whole. So I will use n65. Now I will change only. So y84, y84. Okay. Next n 70. Now x will change. X will change to 95. X 95. So in this way, you have completed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 center drills of all holes. Center drill you have done. Okay. So first option you have completed with this tool. Okay. So after this, you have to stop the cycle. You have to stop the cycle. N75, G80, G80. At this point, the cycle will stop, and you have to give Z equal to 2. Z equal to 2 and M05. M05, that is for spindle stop. Spindle stop. Okay, so instead of this, actually in the programming, instead of here, G00 you have to give over here. Again, G00 Z2. Okay, so again you have to use N80 and G28. So it will move to the homing position. Okay, homing position. And then next N85, you have to use M05 so that the spindle will stop. Now we have to give the tool change call G90. Now we have to use the tool number 2, that is finishing the drill of 6 diameter. 6 diameter. Okay, so this 6 diameter is a through hole. Through hole is there. So 6 diameter finish drill hole of diameter 6, and the depth is as it is taken the origin. You can see over here. This over here to give the depth as per that. Okay, as per that. So you have to first give the tool number call. It is M06, M06, T02. So this tool will be called. Okay, and for that to again specify it speed of cutting speed is 800 and feed is 125. 125 is the feed for that tool, and then you have to start the spindle M03 to starting the spindle. Okay, so here your spindle has been started. Now you have to move that tool to that. Suppose this is the now for this finishing drill, I will use this hole as one then 2, then 3, and 4. For this cycle, I will use drilling cycle. Instead of peg drilling cycle, I will use a drilling cycle. Okay. So for this P02, G81, you have to specify the coordinates. You have to specify the coordinates. So it is the center of this in X direction, it is C over here, and in Y direction it is 84. This center of the first hole. Okay, this hole. Okay, then view that first. G81, X 60, and Y 84. Y 84. Y is at 84. Okay, so now give the depth. The depth will be minus Z minus, this is 40. Suppose I will taking 42 or 2 mm that breakthrough distance. I will use 2 mm or 3 mm. You can take anything. 42. I will use Z 42 and R breakthrough distance is 2 mm. Okay, breakthrough distance is 2 mm. R2. Okay, breakthrough distance is 2 mm. Okay, now it drills first hole. This hole has been completed. As we are using this cycle, so just you have to give the coordinates. Then next that is only y change, 60, then 60, then 60, 60, y 60, and y 60, 40, 60, 40, 60, and then you have to cancel the cycle. Then you have to cancel the cycle. So you have completed all this. Then you have to cancel the cycle 120, 120. So at this point, it will drill the second one, this will third one, and this will fourth one. And now you have to cancel the cycle 80 and just give Z2. Just give Z2, G00, Z2, G00, Z2. Then again 125. This line will be repeated again. G28, so it will go to its home position. Then you have to stop the spindle again. 130, spindle stop. Spindle has been stop over here. Okay. Now you have to change the tool. You have to change the tool that is of diameter 8.5 mm. 8.5 mm diameter for the pre-drilling of this all these tapped holes. You have to do the pre-drilling. Okay. For which hole? So in this you can see the symbol of tapping is there. 1, 2. Suppose this is my 1, this is my 2, this is my 2, this is my third, 4th, 5th, and 6th. Okay, so in this way, it will drill first 8.5 mm diameter with a depth of this. First depth is different, and this depth is also different. This depth is same. Okay, so this depth you have to give first. How much depth is there? So at that time you have to change the z-axis. Then for this 4 holes, for these 2 holes, depth will be the same. For this 4 holes, depth will be the same. So at that time you have to define the depth properly, or otherwise it will not hold up to this depth. Okay. So for this, I will first select the tool, change the tool, M35, 135. Okay, and P03 I will call M06. I will use the starting of the spindle also, M03, P03, that is the tool number. And for this, I will use the speed again, 800. 800 is my spindle speed. And feed rate, I will use again 125. Okay. Then 140, 140, I will use the cycle. Again, G81 cycle I will use, drilling cycle. So first I will cover these two holes with the depth, and again I will cancel that cycle. Then again I will go for the four hole. Okay, because the depths are different for these two holes, and four holes. Okay, so I will make two groups for two depths. So for first depth is it is of a depth 20 mm is the depth, and for the second one it is depth is 10 plus 8. So just a minute, see that first depth is it is not given, I think 20 is the total depth. So I will use 20 is given. First depth is 20, and the second four holes depth are the given is 10 plus that 8, 18 is there. Plus the retracting you have to breakthrough you have to consider over that. So it is have to take, suppose we consider 3 mm for both. For first I will use this 20 20 is the means I will use 18 and 2 mm the retracting, and in this case I will use 18 plus sorry 20 plus this 3 mm breakthrough distance. Okay, so if it is not specified, you have to consider that. Okay, so it will not exceed these two holes. Depth should not exceed this 20 mm, and this should exceed this 18 plus. Means suppose 18 plus we consider a 5 mm for this. It should not exceed this. Okay, we will consider 5 mm. So G81 for the first two holes, we use G21 x. We see the coordinate, x is 20, x is 20, x is 20, and y is 34. X 20, y 34, y 34. Sorry, 84 or 34. Yes, 34. Y 34. Okay, and you have to give the depth. So I will use the depth first, minus, I will use suppose minus 18. I will use minus 18. Okay, and R2, R3. Suppose I will use R3. So 20 and R2, R2. Okay, at this. Then it will drill the first hole. For the second depth hole, you have to give just the coordinate. So it will remain same. So you have to give y 84. I think so. It is 84. Okay. So you have to cancel the cycle here. 150 G80. G80 will cancel the cycle. Okay. G80 will cancel the cycle, and again G80 G00 Z2. Okay. Then again you have to specify again the same tool will be there, and instead of this 180 155 G81 again you have to use and give the x and y. So suppose this is my third hole and fourth hole. This is the fourth, fifth, and sixth. Okay. So third coordinates are 95 is the x, and y is 16. X is 95 and y is 16. Okay. Y is 16, and depth I will take minus 20. Z minus 20. R5. Yes, R5. I will use R5. R5. Now the fourth I will use EN160 coordinates only. Y will be same, only the x coordinate will change. X will be 110, 150. Then 165. This will be the next hole. So for this, x will remain same, y will change. Y will change to 84. Then 170 from this. Now y will remain same for the last hole, and it is 95. X 95. X will be 95. So this completes the twist drill of 8.5 mm diameter holes. Now we have to give the tapping for this last operation. You have to give the tap of 10. So we have to stop this spindle and change the tool. So first we have to cancel this cycle G80. It cancel the cycle G00 Z2. So it will remove up again 180 G28, then 185, hit view, change of tool, M06, then M06, M stop here. First, you have to stop the spindle. I will use now 181, M05. Now we follow the tool T04 and speed is only 200. And speed is to, because it is a tapping operation, speed is increased to 300. Okay, then use 190 M03 starting the spindle. Next 195. Again coordinates will be remain same, all coordinates will remain same, and depth again you have to give repeat this operation. And only the thing is that lines will be repeated, but instead of the cycle, you have to use the threading code for that. So instead of G81, you have to use G84, that is for threading cycle. Okay, but the coordinates will remain same. Okay, because the holes are same, so coordinates will remain same, and depth for that coordinates is also same. So in this, taken the depth instead of this 18, we have taken 2. So we have take that. In this, you have to take 20. In this, you have to take R5 is there, so you have to take 23. Okay. 5 mm the compensation is on there. Okay. Now we have to just repeat that on this ports instead of 81, from this, starting from this line, this to this. Okay, from this all I have to just replace the code, which code, G code, that replace 81 to 84. You have to use only 84, and all the coordinates will remain same. All the next will remain same. Just repeat that. I will rewrite fastly. G84, X20. So this will tab the first Y34, Z minus 20. You have taken 2 mm breakthrough. Then N200, Y84. Just repeat that. 205, G80, cancelling of G00, Z2. Then again 210, G82, sorry, 84, EX95, 516, Z minus 23, R5. X115, N155, y84, x95, and let me cancel it. y84 x95. Okay, n230 g00 z2. Okay, then you have to bring back to the homing position, n235 g28. Okay, g28, that is the homing position, and then 240 m05 and m9 for coolant off, and you can use 245 for m30, that is program stop and reset. So in this way you complete this program. So in examination, the number of holes will be less, okay, or operation will be, holes are more but the operation will be less. Okay, so instead of this different depths and different operations, they will give you a number of 10 12 holes will be there in a block, okay, with the same depth they will give you in the examination. So if or instead of the they will define you that these two questions you have to perform only this phase drilling and this tapping operation. So in this way they will ask you for the examination purpose. So that will cover that. That's one example over this CAN cycle of drilling cycle. So from the next lecture we will see, I will start the simple turning first, simple turning of part programming. Then as we solve the simple problems of link, we will solve first turning of problems. Then after that we will use the cycles for turning of what are do loop cycles. Okay, we'll see that, and then we will see the subroutines for turning also, and then for milling also. The flow will be there, so that will be more understandable for me. So any questions into this session, you can ask me. I will first download your attendance. Okay, any questions? Okay, we will meet on Saturday, and we will discuss over the part programming of turning operation. Okay. Okay. We'll stop my recording now.